Hello and welcome again. So we now are here at the example. So what we want to do is decrypt the message, this message that you see right here. This whole thing, these 4 lines of text, sorry, 4 lines. And this is what it is, the cipher text here that was encrypted using a substitution cipher. So basically what is happening here is I'm playing the role of Eve, the person who intercepted the message. So assuming that this is the message that Alice sent to Bob. Bob got this message and Bob knows how to decrypt it because he has the key. But the problem is Eve doesn't have the key. The only thing that Eve knows is a couple of things. One, that the message corresponds to a message in the English language, and 2, that everything's in uppercase letters. And of course, that it was using the substitution cipher. So as I mentioned in the previous video, the first thing we're going to do is we're going to look at the ciphertext and we're going to identify the smallest word. So we're going to identify the smallest word. So that's the first thing we're going to do. Now, this process that's going to take place now, it might take a while for you to do depending on how quick are you on looking at patterns. Now, it might take a long time, it might take a short time. It depends on how you can see the patterns there. Now, in my case, it's probably taking me longer than everybody else. That's because it's me. But so let's go ahead and do this. And that's why I wrote it down first before actually making the video. So I'm going to identify the smallest words first. So I'm looking at the message. And as you can see there, I put there in the ciphertext, I put a green line below the 1-letter word. So this is the ciphertext, and that H that you see there correspond to the 1-letter word here in the ciphertext. So according to the frequency of 1 single letter words, then the H is going to represent either the A or an I. Now, before I move on, what I want to do is this. I'm going to use some notation when I'm deciphering this ciphertext. When I use the white, when the letters are in white, those white letters are going to correspond to letters that are in the ciphertext. Whenever you see green letters, these letters green are going to be letters that are part of the plain text, the one that I want to know. So from here, I want to know the plain text. So white for encrypted letters, just from the ciphertext, and green for letters that are coming from the plain text. So again, H here is the 1 single letter word. So H probably represents an A or an I. Now, which one is it? We can assume that the letter H represents the letter A. And why is that? Well, let's look at the structure of the ciphertext. If H will represent the letter I, because I is a pronoun, so I should be at the beginning. You see here this is a sentence right here. Start the sentence. So if I have to start the sentence, probably the A, if this were the letter I, it would probably be at the beginning. Similarly here. Now that not works all the time, you have to guess. This is a guessing part that is important. So guessing, in educated guessing, here the guessing will be that H will be the A in that case, because it will kind of not make sense if it is an I. So in this case, what we're going to do is we can assume that the letter H represents the letter A. So H here is the ciphertext, and A will be, in green will be the plain text. So what you're going to do is, once you make that assumption, saying that H represents the letter A, what you're going to do is this. Everywhere you see an H in this ciphertext, then you're going to replace it by A. Because, of course, we're assuming that this letter corresponds to the letter A. So everywhere you see an H, replace it with the letter A. That's why I'm going to use greens to distinguish between what is the ciphertext and what will be my plain text. So to make a distinction, it's just a visual distinction. Okay. All right. So what I'm going to show you next is this ciphertext when I replace the H by the letter A, because I'm assuming that H is A. And again, the reason we say that is because this is a 1 single letter word, and the 1 single letter words in English are either A or an I. So I assume it is A. Okay, so next thing I'm going to show you is everywhere here in the ciphertext, wherever I see an H, I'm going to replace it by A. So this green A here was where the letter H was before. So if I go here, the H you see was here. I'm going to replace this H by A, this H by A, this H by A, and everywhere I see an H, okay, this is another H by A. And I do that for every single letter in the ciphertext, replace it with the A in green, just to make a distinction between the ciphertext and the plain text. So now this is the new kind of combination between ciphertext and plain text. The ciphertext are the ones that are in white, and this A will probably be the letters that are the correct letters, the ones that are coming from the plain text. Okay, so H was replaced. Remember, H was replaced by A. Now, next thing you're gonna do is, okay, are there any more one single letters? It doesn't look like we have any more one single letters. There are two single letters there, but they're kind of difficult to identify, like a CX, here, TN, PQ, ZZ. But there is something that I marked down here, and these three-letter words. This one right here, and this one right here. Now, what are the most common three-letter words in English? Now, go back to that table that I told you in the previous video, and I probably have it here. So I'm gonna have to scroll up all the way to my previous video that you see here, the previous video, and I have the common letter word that actually starts with A, because I already replaced the H by A. So three-letter word that starts with A will probably be this one. It could also be R, right? Or it could also be all, or it could also be any. But let's go with the most common. So we're gonna look at the most common, that's the letter N. So what that means is, if I scroll all the way down until what I was, when I replace the H by A, which is this one right here, H by is what here it was the place for the H, and now it's an A. So I have this one. So I can assume at this point that this three-letter word will be the letter N. So let me write down that. So the word, this word that is right here, A, that's coming. Remember, green is plain text and white is ciphertext. Probably represents this letter N. What does that mean? It means that the letter Z will probably be the letter N, and the letter S will probably be the letter D. Because, of course, I'm assuming that this is the letter N. So this is going to be A and D. So Z will be N and S will be D. So what I'm going to do is now, with this combination of ciphertext and plain text that I have right here, I'm going to replace the letter Z in white by the letter N in green, and the letter S in white by the letter D in green. And remember, green indicates that it's letters coming from the plain text, and white indicates that are letters coming from the ciphertext. So once I do this substitution in here, and what I mean by that is every word you see a Z, you replace it by N. So every word you see a Z, it's set by N. So I'm going to replace this by N. And everywhere I see a Z, anywhere in this text here, I'm going to replace it by N. And everywhere I see an S, I'm going to replace it by D. And when you do this by hand, I suggest that you do it using colors as well, because it's going to make it easier for you. All right, so to distinguish which one is the ciphertext and which one is the plain text. So after I make this substitution, replacing Z by N and S by D, we're going to get the following text. So as you can see there, I replace all the Z's by N and all the S's by D. So this is the new combination of plain text and ciphertext that I have. All right. So far we have identified one single letter words and three letter words, and we are looking a little bit more promising. Also, okay, so what else can we do? Now keep looking at small words. So let's look at small words here. So I'm interested in these small words, this two-letter word that is here, and this two-letter word that is right here. So what you're gonna do is this. Let's look at this guy right here. This one, the CN first. The word CN, the one that is right here, probably represents the word in. And the reason for that is because you go back to that fact that gives you the frequency of the two-letter words. And in, a word that ends in N, that is a two-letter word, will probably be this one, in. Okay, I'm going to go all the way up to show you that that in is a common two-letter word that ends with N. So this one here. So I'm guessing that this is going to be in. So let me go scroll all the way up and look at the two-letter words here. Two-letter word that ends with N, the in is the most common. So what that means is the following things. I'm going to scroll back down here until I get here. So a two-letter word that ends in N is probably in. So that's why we can make the assumption that the word CN, this word CN, will represent the word in. What that will mean is that the letter C of the ciphertext will correspond to the letter I in the plain text. So what I'm going to do now is exactly the same as before. I take the letter C and I'm going to replace it by the letter I in green. Everywhere in this message, everywhere you see a C, you replace it by I, right? So for example, here in this word here, you see a C there. I'm going to replace that C by the letter I. So let's do that. And another word that you see here, there's a two-letter that starts with N, two-letter, and T. If you go back again to the list of two-letter words that start with N, no is going to be one of the most common. So what does that mean? It means that letter T from the ciphertext will correspond to the letter O in the plain text. So we're going to do two replacements in this case because we are looking at two different words. For the CN, we're guessing the CN corresponds to in, so replace C by I. And for the word NT that is up here, NT probably is the word no, so we're going to replace the T by O. So the next text that I'm going to show you is this one when I do these two replacements. This replacement right here, C by I and T by O. So let's look at that one. So this is the new text that you see here. So this is a new text. All right. Keep looking at small words because remember, this is all about guessing and frequency. So we have used that a lot so far. And it's looking a little bit better. There are some words that are coming up nicely, like this one, for example. And there, A. And let's see here. If you see, I marked this down with green. O-N-O. Now, O-N, they're coming from the plain text, but O is the ciphertext. So this O here is different from this O. This is from the plain text, and this white O is from the ciphertext. This is a three-letter word from the English language. So what word do you think this one represents? You probably guessed correctly. That word represents the letter 1. So what does that mean? It means that the letter O from the ciphertext will probably correspond to the letter E. And so what you do is you make the replacement. So the replacement will be every word you see an O, you replace it by the letter E. So here, the white O will be replaced by the letter E. The green O's are going to be not replaced because they are already the plain text. You are replacing only the ciphertext letters. Now, as you can see here, this is just kind of guessing, but it's an educated guessing. Now, how do you know you're doing the right thing? You're going to know that you're doing the right thing if this text here is making kind of sense. It's making sense in the English language. Of course, when you are done, there is nothing that says you successfully decrypted the message. Nobody's going to tell you that. How do you know you actually made it? You made it when this kind of makes sense in the English language. So let's keep going. Replace the O by E. So everywhere you see a white O, you're going to replace it by a green E. So if we do that, then it's going to come up like this. Of course, no, here. The one that was O there was replaced by E. And the other O's, for example, this one that was here was replaced by E. As you can see there, this green O was not replaced by E because that is the plain text. I don't have to replace anything that is coming from the plain text. All right, so let's continue doing or looking at small words. So once more, you can see here, I'm marking this word down. So this is a 2-letter word that ends in O. So what you have to do again is you go back to that list of words that I told you that are the most common 2 single-letter words and see which one is the one that ends at O. So as you can see here, if you go back to that list, I'm not going to go back again because it's now too far up. But the word EO means that I have a 2-letter word that ends in O. So what is that? That's probably the 2-word 2. And so what that would mean is that the letter E will correspond to the letter T. So the letter E in the ciphertext will correspond to the letter T. So everywhere here now in this text, I'm going to replace everywhere I see a white E, I'm going to replace it by a green T. And that's what you're going to see next. So then this word here, of course, will become 2. This word right here. And again, you replace every E, white E, by T. Okay. So once you do that, then this is the text that you're going to get. Of course, when you're doing this by hand, this is going to take you a little bit of time because as you can see, you have to look for the letter E everywhere in the text, white E, and replace it by green T. So it's going to be a little bit tedious to actually go through all this text and replace it. So I suggest you use an eraser for that and use colors because it's going to make your life a lot easier if you do that. Okay, so now let's look at this new text that we got by replacing the white E by the green T. So this is what we have now. Now, maybe you might be much better than me in doing this. And because I'm a little bit less trained in the English language, I have to look a little bit further to understand what the whole text is. Now, let me look at a couple of things here in this new text. If you see this word here that I'm marking down with green, this one, that looks like the letter or the word understand. Now, that word was not in the list I gave you, but it just looks like that. It looks like the word understand. What about this 2-letter word, IX? Now, I can guess this one from the pattern. This is the pattern recognition that you need to use. And of course, there is no actually rule for it. You just have to look at it and can you recognize that word there? Well, I can actually recognize it. It looks like it's the word understand. How about this 2-letter word here? It looks like it is, right? Because it's a what is the common 2-letter word that starts with I, is. Again, you have to go back to that list of words that I gave you. So this is what I'm saying here. So the word that you see here, IX, probably represents the letter is. What that means is I'm going to replace the letter X in white by the letter S in green. X in white by S in green. And of course, you have to do it everywhere where the white X appears. You replace it by the green S. And because we kind of recognize this word here as the word understand, then the word, that one that is right here, combination of whites and greens, will probably represent the word understand. So from here, I'm actually getting this X here was actually coming from this word, if you actually guess it. But there's something else coming from here. So the word, if this word represents the letter, the word understand, then P will represent the letter U, and N will represent the letter R. And of course, X was S already there. So actually in this step, I'm replacing 3 letters. So just by looking at this word and this 2-letter word, I'm replacing the X by S, the white P by the green U, and the white N by the green R. So I'm gonna get that replaced there. So as you can see, it's getting a little bit better. You can actually probably guess now what this is. So I'm gonna go ahead and replace it. And again, you have to do this by guessing and educated guessing. And this is the educated guess we did here we know some information, and then we guess what it goes after. So three letters are replaced here. So when you do that, this is what you're gonna get, this new text. As you can see, this is looking a lot better now. So for example, we have here another word that is disaster, hour, it came from free. And so it's looking a little bit better. It's looking more like an English kind of paragraph. What else can we see? Okay, so I'll mark this down, this word here, and this other word. What word do you think this one is? Is arranged, probably arranged, and this is probably the 4-letter word, that. So let's go with that. So this is another educated guess. So the educated guess here is that the word that you see here, this one, is the word, this one is the word arranged, and this 4-letter word that you see here is the word that. So by using only the arrange, then I can say, if that's the case, if this word represents the word arranged, it means the letter V and white, or the cipher text, will be represented by the letter G in the plain text. Also, by looking at that 4-letter word, then I can say that, of course, the letter L will be the letter H. So I'm going to do 2 replacements at this point. So I'm going to replace the white V with the green G and the white L with the green H. So let's do that. And of course, you do it over here from the previous text. All right, so if we do that, you can see here this is looking a lot better. You probably know what it is now, right? But let's keep going. So I'm marking down another word that I kind of recognize here. It has like a pattern that I recognize, this word here. Now what that word looks like, the word almost looks like. So let's go with that. Let's have here the educated guess of saying that this word that here is here, the 6-letter word, is almost. So if we go with that, if we say that that word, this one, probably represents this word almost, then I can do a little more. I can replace white M by green L. Remember, you usually replace the white M. You don't replace the green M's. You never replace anything that is green. You only replace things that are white. So you take a white M and you're gonna replace it with L. And you're gonna take a white F and you're gonna replace it with green M. So let's do that. So from here, we're gonna do that replacement. Of course, this word will become almost if we do that. So let's go to the next one. As you can see there, then now we have the word almost, and everything is looking a lot more better than before. Let's go a little bit more. You can probably guess now. You probably guess what this is from a while ago, but I have to do a little bit more. So what is this word here at the beginning? So we have a 2-letter word that ends in E. And because we are having this here and this other one that is here, what words do you think this one represents? Well, it's right there, right? So this 2-letter word will probably represent the letter V. And this 4-letter word will probably be half. So let's go with that educated guess. So we're going to say that this one represents the 2-letter word V. So what that means is we're going to replace the white J with the green W. In a similar way, we're going to do this one here with half. So this will probably represent, this word here will probably represent the word half. So we're going to go with this replacement. So we're going to replace the YK with the green V. And something else here, this word at the top of the text. You can probably recognize what that is. It's probably technology. So what that means is I can actually replace the I and the W by the corresponding letters in the word technology. So the word technology, this probably is the word technology by the educated guess. We represent this one. What that means is that the letter I will be white I will be replaced by C, and the white W will be replaced by Y. So in this case, I'm replacing 4 letters at once. So the J by the green W, the K by the green V, the I by the green C, and the W by the green Y. And that is going to be taking place from here. I'm going to replace it in all this text. So if you go ahead and do that, this is what you get. Right? This is here. It's almost completely decrypted. You can actually read it right now. But let's keep going. What else can we see from here? So let's see some other stuff. So this 3-letter word here, and this 4-letter, and this 5-letter. Now this letter that you see here, the first one, it does look like the letter, like the 5-letter word power. So the word, this one that is right here, will probably represent the word power. What that means is that the letter Q is probably the letter P. So green, the white Q will be replaced by the letter P in this. And this 3-letter here that is here, if you look at the 3-letter words that end with UT, then this U is probably a B. So this one here will probably be but. So the U, white U, will be replaced by the letter green B. And one more thing is one here, this 4-letter ULOW with the LOW are from the plain text and the white is coming from the ciphertext. Then actually we don't have to do that one. So let's just do the replacement for the other ones. If actually we do Q by P and white U by green B, we replace everything from here. And we actually get what the plain text was. Now remember, this is it's a process that could take a long time depending on how quick are you for recognizing the patterns. So this is actually the plain text that was sent. Now this was a lot of educated guessing, looking at the English language, the frequency of the letters. If the language is different, then of course this analysis will be different, in the sense that we have to take into consideration different frequencies of different one single words, 2-letter words, and so on and so forth. But this is the actual message that was sent from Alice to Bob. So as you can see, we can crack the substitution cipher as long as the message is long enough. You see here, you need a long message to make educated guess. If the message is just a 4-letter word, well, if it is a 4-letter word, it could be any 4-letter word in the English language. So there's not much information there. But if you have a long enough ciphertext, then you can pretty much decipher the substitution cipher. So that's pretty much all I have to say about this. All the examples are going to be almost like this. Of course, the analysis is different because you're going to have different letters. And I suggest when you do this, you use colors. Use one color for the ciphertext and another color for the plain text, and be ready to erase a lot and do trial and errors. So sometimes you try something, it doesn't work, then you have to go back one step. So keep the previous steps that you do with this process, because you might have to repeat one step again. So that's all I have to say about the cracking of this substitution cipher. I hope this was helpful for you, and I'll see you next time in the next video.